To all the guests, To all the guests and visionaries, a very warm welcome to a momentous occasion that marks a union of innovation and intellect and limitless expanse of space. I am thrilled to stand before you today as we embark on an extraordinary journey with the realms of technology and innovation. Here at Techfest Iit Bombay, we are privileged to have this platform where dreams meet reality and aspirations transcend the ordinary. As we eagerly anticipate the insights and wisdom our esteemed guest is about to share, let's remember the power of collective imagination and impact of innovation of our future. So, with a huge round of applause, let's welcome the chairperson of ISRO, Shri Somnath. With a huge round of applause, let's welcome the head of Aerospace Department, Professor A.M. Pradeep. Everybody please sit down on your seats. This isn't just any event, it's a gathering of thousands of curious minds, all here to witness an icon in space exploration. Today we have the distinct honor of hosting the chairman of Indian Space Research Organization, Shri Somnath, an individual whose dedication and visionary leadership have propelled the India space missions to unprecedented heights. Now, I'll urge the Dean of Student Affairs, Professor Suryanarayan Dula, to extend a heartfelt welcome as we present the bouquet to the esteemed chairperson of ISRO, Shri Somnath. With profound gratitude, we are privileged to have Professor A.M. Pradeep, the head of Aerospace Department, to grace this occasion. So now I'll urge Neha to join me in extending a heartfelt welcome as we present the bouquet to the professor. Please give a huge round of applause. Now, I would like to hand over the mic to Professor to embrace us with an insightful discussion with Chairperson of ISRO, Shri Somnath.
So, good afternoon to all of you. I think it's indeed an honor and privilege, I think, for all of us to be here today to listen to our esteemed speaker. So, Shri Somnath doesn't really require any introduction, but I think I'll still do the formality with his kind permission. Just a few highlights. I have actually 2 pages of his CV. I'm not going to read that out. I will just restrict my introduction to the bare minimum and give more time to the speaker and so that you can listen to him. So as you're aware, Shri Somnath is currently Secretary, Department of Space and Chairperson of ISRO, and he took charge almost 2 years back in Jan 2022. Prior to this, he has been the director of Vikram Sarabhai Space Center, and even prior to that, he was the director of Liquid Propulsion Space Center. And during these, as well as his prior tenures, Shri Somnath has been instrumental in various very important missions and experimental projects as well. I'll just list out a few of them, which sort of are the highlights of his association with ISRO. He has been the project director of GSLV Mark III and also the first experimental flight of LMV-3 X-Care mission, which was close to 2014 that it was demonstrated. Shri Somnath's expertise is in systems engineering of launch vehicles. It's a rare expertise that we have in this country. And his contributions in PSLV, GSLV Mark III were essentially in their overall architecture, propulsion stage design, structural dynamics, separation systems, etc. While his tenure at LPSC, he also led a team to complete the development and qualification of CE-20 cryogenic engine and the C-25 stage, which was successfully flown in the GSLV Mark III D1 flight. The development of throttleable engines for the lander craft of Chandrayaan-2 was another important developmental activity that happened under his leadership. Actually, the list goes on and on. I'm sure you're all eagerly waiting for his talk. Besides numerous other achievements and accolades, which I can keep on reading, I think I will skip that in the interest of time. We will also have enough time at the end for questions and interactions with the audience. So with these few words, I request Sir to please take over the stage and address the audience. Do we have a caller mic?
Go to my. So, good afternoon, all of you. The brightest light is too bright that I'm not able to see anyone's face. So it looks like I'm speaking to a dark space in front of me. So if you can switch on a little bit of light, then I can see the faces and see the reactions. Organizers, please help me. Yeah, good. Now again, more light on my face. Okay, good. So thank you so much. Good afternoon once again. The topic given to me is to speak today on the Indian Space Odyssey, advancements, challenges, and the road ahead. First of all, let me thank the IIT Mumbai, Bombay, and also the Techfest organizers for having me here today. I think all of you are excited about space now after the landing of the Chandrayaan-3. I'm very sure about it. But I am excited more of the possibilities that are there in front of us in the future. And the type of road ahead has been now defined very well now, reasonably well. And the type of challenges in front is really exciting me, though I won't be there in ISRO to see all of that to happen because it's going to be by 2040 in the Amrit Kal. So I'm really expecting my next generation of leaders that are going to take over and do this work. It's really going to be really the stars. They are going to do this work for that. So my task today is not only to outline the roadmap, but also identify those people, the leaders, who will be able to execute them, and especially those youngsters who will be able to design those things in the coming 25 years. So that's why I'm excited to come to IIT. IIT is like, in fact, I gave a talk at IIT Chennai some time back, and this is a similar event where I am really happy to talk to you people here. Though possibly you would have heard about my speaking about IITs and their contribution to the space program. I think I won't be getting into that domain at all today, but I hope that I'll be happy to see more of IITians joining space program and contributing towards nation building in this domain. So with that introduction, let me go into the topic. No, it's not moving. So we recently celebrated the 60 years of the rocketry. The way back at Tumba, we had the small rocket launched. You can see the iconic pictures of the parts of the rocket being carried and the bicycle, and that happened in November 21st, 1963. So in November 25, we had a similar demonstration of a launch of a small rocket there at Tumba, exactly from the same location. Our minister was there. But then more than that, what we achieved in this 60 years of time through the rockets building, satellite building, launchers, and the infrastructure that we created, a really significant number for a country like us. Okay. So today ISRO is organized under these verticals, like any business establishment we call verticals. So we have the rocket building, we call it space transportation, the space infrastructure, the spacecrafts building, design and making, also the space applications. The Gagarian program, the human spaceflight program, is going to be one of the most important one. And of course, the capacity building across various domains in creating leadership, technology leadership, as well as planning and managing leadership, international collaborations, R&D capabilities in the organization. All of these are going to be very, very important. Today we have the rockets, which are the workhorse for us. The PSLV continue to fly very well, and we are going to have the 60th launch of the PSLV now on 1st of Jan 2024. So that's going to be another history. And the rocket LVM-3, which is going to be the one which is going to take human beings to space. And it also did a very interesting mission like the OneWeb India mission, 2 of them successfully deploying almost 72 satellites in 2 missions for an international customer, which was very, very critical. Came in a very short notice due to the Ukraine-Russian war. That was a possibility that it opened in front of us in short time to re-engineer our cryogenic stage to deploy 34 satellites in one go, and we could do it very, very well. And today we have a type of space infrastructure in operation. The number of satellites we have 18 communication satellites currently serving the country in various sectors, 25 Earth observation satellites, 8 of the navigation satellites, and the science mission satellites. Of course, the numbers are going to increase. I will tell you a little later. So the same thing, the science missions which are Chandrayaan-2, Chandrayaan-3, as well as Aditya L1 are still operational, and also the Astrosat, which is not mentioned there. That's also currently working. I think all of you are aware of these satellites, so I won't spend time on it. See, some of the new satellites which are coming up is very interesting, and many of you may be likely to know these aspects. The INSAT 3DS, it's a new generation weather satellite, and we are going to launch it in this January month itself. The satellite is in the final phase of getting ready. It has a beautiful payloads to measure the various climate parameters and give the synoptic view of the Indian continent, give it in water vapor and other infrared emissions, as well as the temperature distribution, the formation of the cyclonic genesis, and all this it can find out. And this is going to be one of the very important satellites for our country, and this is going to be launched using GSLV. RESAT 1B is another interesting radar satellite we are going to launch, which has a very high resolution radar imaging, specifically for day and night viewing of the entire country, maybe the world also. OceanSat 3A is another important satellite to look at the ocean, which is we have just now launched. Then ResourceSat 3A is another satellite which is looking at the Earth, specifically the land mass, the vegetation, the cartographic data, etc. And ResourceSat 3A is yet another variety of the Earth imaging satellite. And possibly you are all aware of the NASA, ISRO synthetic aperture radar satellite. It was a huge antenna, 18 meter in diameter, and 2 synthetic aperture radar bands, L and S band, which is going to map the entire Earth in every 12 days. And what it's going to find out is really the tectonic movements in centimeter level accuracy. So it gives us an understanding of the movement of the whole of the plates movement, which is linked to somewhat the utilization of the water there. For example, if you draw too much of groundwater, you can actually see a dip in the land. And we know that the land surface actually moves up and down by almost a meter in cyclic nature, because when water is drawn too much, it actually dips, and when water is recharged, it actually comes up. And many of us don't even recognize that our buildings are moving up and down almost a meter every cyclic way. And this can actually measure it in centimeter accuracy and understand how these movements will be useful in understanding various aspects of Earth, like the tectonic movements, the water utilization, the ice sheets changes in the glaciers as well as in the poles. And it also measures even water vapor content, water content on the soil. So water stressing, it can find out, it can help in agriculture and various ways because of these two important synthetic aperture radar capability. And this satellite is just getting ready now. By middle of maybe the first quarter of next year, we will have this launch. And Trishna is another interesting payload which is going to come up as a joint working between ISRO and CNES, the French Space Agency. And we are working on a thermal imaging. Thermal imaging is so important that if you look at the infrared emissions from surface, that you can actually see much more that you cannot see with your eyes. For example, that if there is a water stress on a crop, then we can understand it very well. For example, that. And there are many more capabilities with thermal imaging, which I will not explain here. So this is another research satellite which we are going to launch. Of course, this is a new announcement that we are given, that the government has announced that we are going to have a G20 satellite for climate and weather. I think all of you realize that weather and climate change is going to be a very important aspect as far as human beings are concerned. It's a hot topic of discussion. And we want to make sure that we contribute to this domain by measuring various parameters. For example, the air pollution, the greenhouse gas emission, forest fires, humidity change and precipitation, ocean behavior, currents, waves, soil moisture, radiation budgeting. All of this we can measure through a single satellite. It's going to be a wonderful thing. So we offered to build a satellite of this, and we are asking the G20 nations to contribute on this satellite. So through payloads or through instruments that they can develop, we are hosting this and going to be launched in 2 years. I think this is going to be the contribution of India to the whole of the world. And we want to make sure this data is available to the entire world, every nation, for that they can use it for their weather modeling, scientific research, etc. And we are welcoming each one of us, each one of the scientific community in all the nations to contribute and come and build a satellite for the world. This is a very unique initiative by the government now. Of course, this is another satellite we are going to build for agriculture as a focus. I think all of you know that while ISRO started building the space program, we were working on thematic applications, agriculture, weather, water, land and land resources. So again, back on this similar lines, we are trying to build one satellite for agriculture. Then you will wonder what exactly is agriculture that we are talking about. When we move on from the current method of agriculture to more precision agriculture, the remote sensing data becomes very, very useful. For example, if you want to find out how a particular area is water stressed and how to use the irrigation to be enhanced at some zones, if the soil is not rich enough to support that particular agriculture, how you can change the crop rotation can be done, drought assessment, and of course, governmental funding schemes are linked with these images, and we can even connect that way so that if some states requires agricultural support in terms of money to handle the drought and other crop stress and diseases, then the data from this will be very, very useful. And yield estimates, it's again very important from the export-import decisions making. And we can make this in very fast, and there is a demand from the Agriculture Ministry itself to build it by ISRO to support this sector. And of course, all of you know that crop insurance is another very important area which has a huge business potential of almost 50,000 to 1 lakh crores per year. That is dependent on the ability to predict the crop growth and crop yield very well. Yet another domain which we have to work out is the intelligence. I think all of you know that spacecrafts are capable of observing the whole of the country, its borders, the neighbors, and all of them can be seen from satellites. And this capability gives us an enormous potential. We have been launching satellites to handle this, but then there is a different way of thinking now happening, that we need to look at it in much more critical manner, because the power of a nation is a function about the ability to understand what is happening around it. And if you can really launch satellites in numbers and look at it in various ways, our ability to handle potential adversaries and threats can be better mitigated. So we have found out a way by which this layered architecture of satellites can be launched, starting from GEO to LEO, and also very low orbit also in case where we need to have a very critical assessment of some situation. So this is a new domain which is coming up now, not only in optical, but SAR, thermal, and various other technologies get fused into it. And not only that, we will have communication between satellites, so that if some satellite detects something which is at GEO at 36,000 kilometers, it can have a large view. And if you find some activity happening, you can task or another satellite which is in the lower orbit to look at it much more carefully and then give more information. And this information will be, actually not just images. It will make an AI-based intelligence gathering. For example, change detection. For example, it can be a troop movement or any such activities can be detected. And we can create a layered architecture of satellites to handle intelligence in the coming days. And for that, many satellites are getting designed and configured today. We have already configured 50 satellites to be realized in the next 5 years. And this is going to be launched for India for supporting this particular geo intelligence capability over next 5 years plus. So I'm not going to the technology because they are going to be very, very critical and crucial, strategic importance. So I will not be discussing all of that. But then this is going to be one of the important tasks in front of us today, to improve the ability of the satellites to detect changes, to bring in more of AI and data-driven approaches to analyze the data that comes from that, reduce the data downloads, and get only information what is necessary. I think these changes are going to happen in the coming days in terms of the new technologies in various ways. And we are also looking at imaging, not very small area, thousands of kilometer area, and we would like to cover the entire borders in everyday cycle. I think this is a tremendous capability that you are building if you are able to launch all these satellites in the next 5 years of time. Of course, in the communication sector, you will see large amount of changes, demands coming in the communication satellites. Already you are aware that the LEO communication constellations like the Starlink, OneWeb, and others are really trying to change the way in which that we use satellites for communication. Now we are looking at handheld devices directly accessing internet through satellites possible now, but it has not still become operational. But then it's going to happen now. Of course, there is high bandwidth data transmission needed, for example, streaming of movies while we are in flight or in ships, etc. Or even in remote places, you will be able to get a high-speed internet connectivity directly from satellites. That means broadband access is going to be very important. And we have to have satellites which is technology upgradable while it is in orbit. I think this is another important issue. Today, when we build a satellite and launch, typically the life of a satellite is 15 years. And in 15 years, technology changes so much. By the end of 5th year, the satellite is not as efficient as it used to be in the very first year. So we will have to repurpose the satellite by making changes in the software, maybe sometimes making changes in this location or in frequency or the way in which it is utilized. So we call it software-driven satellites. So we call it a flexible satellite. Everything can be changed. For example, its orbit location can be changed, its frequency can be changed, the nature by which the beams are given can be changed. So a software-driven satellite is another technology. Remote mobile access, optical communication is another technology which is going to come. If you have to really have high bandwidth communication, we need to have optical communication. It's not possible with the RF domain. The threshold has already reached, so we have to go to this. And another important area is secured communication. Because communication breach is very, very critical, and data security is important, communication security is important. So secured communication has to happen. For that, we are building our first quantum key distribution satellite soon. In another 1 year, we should be able to make, I will come to that a little later. The satellite-based quantum communication is very, very important, and we realize that we have right now made some technology demonstrations. The quantum key distribution is the essence of it. So we will have multiple satellites which will be generating those keys and distributing over to various terrestrial stations. And this will be used for encrypting the terrestrial communication networks like the fiber optic communication networks, etc. So that it will be a quantum key based protection will be enabled in all the communication networks that we use for even terrestrial communication in the future. So the single photon based as well as entangled photon based schemes have been made, and we have also demonstrated recently. The approach is like this, that we will have a geo satellite which is more or less stationary, then a low Earth orbit satellite which is rotating about an orbit in low Earth orbit, which will be communicating with the classical ground station networks and then providing the key distribution. So we will have also optical link between the geo satellites to low Earth orbit as well as the low Earth orbit to another low Earth orbit satellite. So we will be in a position to send very secure communication networks, because optical communication is said to be much more secure than RF communication, and it is very directional. So others will not be able to access those communication networks. So this is the approach that we are trying to build it soon. And recently we conducted similar experiments at our ISRO facilities, where we were able to establish a quantum key distribution demonstration over on a daylight time, so that it can be actually successfully employed in one of the launches. And in fact, we scheduled for launch in the last launch of PSLV, but couldn't happen due to some readiness issue. I think soon you will hear about it, launching this as a demonstration in the orbit. Another important communication requirement that is coming up in the future is to identify ships and aircrafts that are flying in our air space as well as the ocean. I think thousands of ships are moving around, which includes friendly ships and not so friendly ships. And we need to track them, we need to find out them about various activities that are taking place in our oceans as well as skies. So this is called automatic dependent surveillance broadcasting, and also has to have access both on large space, like the ship. If you have to cover the entire ocean, it's very difficult with one satellite or single satellite. So we are planning a constellation of satellites to handle this particular issue of identification of ships and identification of aircrafts. Today, you know that all the aircrafts identification happens by the Airport Authority of India, and this all data is purchased. It's not actually sourced from India. India doesn't have our own identification satellite, identification of objects, payloads in any of our satellites. So this is a new domain, and we are developing it. We have also demonstrated a payload recently. We launched it on SSLV launch, and we could get beautiful data from that satellite, how to identify, because every aircraft transmits a signal, and we can pick it and identify exactly where an aircraft is moving, which direction it is moving. It will help the airport authority as well as air traffic management people to plan the entire trajectory. So this is another important work which will demand large number of satellites to be built and launched in the coming days. Satellite navigation, as all of you are aware of NAVIC, like the GPS, is another important contribution that ISRO has done recently. And we made it more people-friendly by inducting a new frequency called L1 band. Possibly you are aware that NAVIC is already there for last many years, but it has not penetrated into your mobile phones or into the day-to-day devices. So this is primarily because it doesn't have the frequency of the GPS. And we realized it, and we made sure that the next generation of satellites will be always equipped with the frequencies which are GPS frequencies, so that you don't have to add any additional chips or hardwares to handle it. Only a software patch is enough in your mobile phones to handle NAVIC. So all your mobiles will soon become NAVIC and friendly. It's already, iPhones are already, the next generation iPhones are already coming up with NAVIC-friendly multi-GNSS capability. So, but it will take 2 more years for us to make it full-fledged launches of all satellites in L1 band and make it available to you as a service. But all of you know that NAVIC is not meant for civilian use. NAVIC is meant for strategic use. And this is very secured strategic use for our forces to use for people movement, vehicle movement, as well as armaments deployment. And this is a very secured, key, controlled data, which is not available civilian front. And this will be in a different set of frequencies called S and L band, not the L1 band. S and L5 band, not L1 band. So L1 band and L2 band are the citizen bands, which will be available for GPS people, like the GPS people soon in NAVIC as well. So not only that, we are going to make a regional navigation system, which is currently the NAVIC, like the many other global navigation system. We would like to expand NAVIC to cover the entire globe, or reasonably wider field than what we have today, which is just 1,500 kilometers beyond the boundaries of the nation. but we would like to expand it to cover more areas of interest in the future. So there is a plan to expand it in the coming days. So I just now mentioned about various domains that we are trying to expand, how our satellites can become useful, and how many more satellites will need to be built in the coming years. I think if you have counted the number of satellites to be built, it will run into hundreds. So this is the new demand that has come from space today. So Chandrayaan-3 and Aditya L1, etc. are one of those satellites which are very exciting for all of you. But the real work is in building very complex satellites of this nature, the communication satellites, like the software-driven satellites, the very high resolution and very agile remote sensing satellites to handle the strategic use, NAVIC expansion for civilian utility, and various other communication networks that like the quantum key distribution, etc. I think all of these are really technologically very challenging work, and we made sure that we have a roadmap of building all of this for the coming days so that our overall satellite fleet, which is currently only 54, which is just not enough for a nation like India, which is aspiring to be a powerful, strong nation. I think it must be 10 times more than what we have today. So to meet all these demands, that type of growth is needed in this sector. And this is something that we were convinced, and then we were planning to work for it in the coming 10 to 20 years of time. Now, there are other new technologies which are important, like satellites, rockets, and other access to space is equally important. We have done the crew escape system demonstration, and we would like to use the same rocket to demonstrate the vertical landing. You would have seen the test vehicle flight in the videos recently, and this vehicle is capable of doing many things. And we have made sure the engine used in that rocket is a throttleable engine. A bipropellant engine with a throttleable capability has been built in. So we can actually use it for vertical landing demonstration. So vertical landing of a conventional rocket is already proven. I think you know two of those people like Elon Musk, SpaceX, Falcon 9, also the Blue Origins is also doing that similar exercise. So, but to demonstrate for Indian use, we would like to have a technology demonstration program. And similarly, we would like to use it for the air-breathing engine, which is at a hypersonic speeds, which is very crucial for us in the strategic sector. We also want to use the same rocket for example, like a space tourism vehicle demonstration also. So the whole idea of the crew escape system demonstration test vehicle is to use it in multiple platforms and develop this capability, extremely low cost approach. I will not disclose you the cost, of course, See, one of the important things we are trying to work out is the air-breathing engine. This is a scramjet-based kerosene as a fuel. Earlier, we had done a demonstration with the gaseous hydrogen as a fuel, but kerosene is important because it reduces overall volume of storage compared to hydrogen. And we can get a very long duration flight, like 250 seconds of long duration flight in such a mission. And this is very crucial for us to have hypersonic vehicle capability for various reasons. And this is currently under development, and we have already tested those elements of those scramjet testing earlier with hydrogen, and now we are done with kerosene, and we're using many support systems that we have in this country. The people like NAL and our ISRO's own facilities are equipped with the testing these engines in the ground by vitiated air. Vitiated air is something that is called, the air is heated up to the conditions which will be felt at the stagnation point temperatures at the inlet of the scramjet engine by burning kerosene inside and then heating the whole gas and replacing the oxygen that has been gained by additional feed of oxygen. So this air is used to test these engines, and we have successfully tested these engines recently. Of course, all of you are aware of the Chandrayaan-3, and I would like to look at our long-term plan beyond Chandrayaan-3. And Chandrayaan-3 has been a great success now after the Chandrayaan-2 debacle of not able to land softly on the surface of the moon. I think we have made that essential changes that are necessary in the overall program of landing on the surface that made ultimately the Chandrayaan-3 succeed. I think they really gave a lot of confidence to us and a lot of confidence to the whole of the team to work on future programs. Even the rover has done fantastically well in the experiments. I think two of those experiments on board, such a cute rover, especially doing the mineralogical experiments. I think you can imagine for such a small rover how we packed that much of stuff inside. You know that it has two important payloads called the X-ray spectrography put inside. It actually emits a alpha particle into the material. It causes the X-ray fluorescence, and you measure that and then do the spectroscopy. Similarly, we had another laser which is ablating the materials, and then the ablation is actually captured by the spectroscope and then elemental composition analyzed. And it also has deployment mechanisms for all these payloads. Its transmission capability, imaging capability gave us that beautiful picture. Without those cameras on that rover Pragyan, we wouldn't have got that classical picture of the Chandrayaan-3 on the surface, and none of you would have believed that it ever landed on the moon. And we had beautiful obstacle avoidance capability and demonstrated it was almost going to fall into a crevice or some ditch there, but it found out, and then we were able to analyze the image and then take a detour. Almost 100 meters it traveled on the surface. But all of you know that today it's after the 14 days of its contribution of collecting data, it is now sleeping very well there. So I advise my team not to wake it up again. So it is sleeping forever for the history. But unfortunately, that we were hoping that it will wake up through its ability, but then it couldn't happen, because whenever we tested the whole system in our laboratory going up to the temperature, it was working. But when you go up to the moon, the situations are quite different. There are different issues like radiation, the extreme conditions that are encountered there may not be fully simulatable in ground. That could be the reason why some of the system would have gone bad, like the electronic boards or the soldering or the materials that are used in that could have damaged the whole circuits. So many things could have gone wrong, and that's why it is not able to wake up again. Possibly, even if the Pragyan would have woken up, we will not know, because unless a communication link between Pragyan and the Vikram is not established, or in the Vikram some packages are non-functioning, still we will not know about it. Because it's not waking up alone is enough. We need to have communication system which is healthy to know about it. So we hope that whatever data that we collected in 14 days of Earth days is going to give us fantastic scientific outcome in the coming days, and our scientists are working on it now. And Aditya L1 is almost there now. Aditya L1 is going to reach the Lagrangian point on 6th of January at 4 p.m. I think all of you are watch out for that announcement. So at 4 p.m. We will have a very controlled burn of the engine of the Aditya L1 so that it enters into the orbit called the halo orbit. It's a very interesting orbit. Possibly you can read it in our website, how it is going to be. Lagrangian point is a theoretical point, but reality Lagrangian point is not just that point where you can go and keep the satellite. It's a region where the gravity of between Earth and Sun will neutralize. But there is absolute neutralization is not possible, because there are other bodies, like the moon is moving around. So moon will perturb that. And there are other objects like Mars, Venus, all of them are causing some disturbance to the gravity field. So net result of multi-body problem is that you get a region which is gravity neutral. So the satellite will move around in a zone which is a three-dimensional space, and that point is called the Lagrangian point halo orbit, and we'll be inserting it so precisely in that. It's a complex calculation which enables us to inject the satellites at the precise location. And all the 6 payloads are working beautifully now. We have tested them, and all of them are giving very good data, and we hope that after this insertion, the satellite will be destined to look at the sun forever. Forever means as long as its electronics inside are healthy and ready to transmit the data. And we hope to find out a lot of correlation between the solar coronal mass ejection and later impact on the space weather that we are facing every day. In the coming days, we are going to have many more interesting scientific missions. XPOSat is already at the launch pad. It's all getting ready for launch on 1st of Jan at 9:10 a.m. And you can all watch live on TV. And XPOSat is the first dedicated satellite for polarization measurements in medium X-ray range. And this is going to find out something very interesting about black holes and its ability to eat into other stars. Once black holes take raw material from adjacent stars, there will be an X-ray radiation. And X-ray emission will be the polarization nature of that X-ray emission. If you are able to measure, you can actually quantify the material ejection. This is the theory says, and I am not very sure about it. But still, we are going to do that measurement and then find out using 2 payloads on board, one by Raman Research Institute at Bangalore and another by ISRO. We are working on various new future missions like the Venus orbiter, the Mars lander, a lunar sample return, and also a lunar polar exploration mission in collaboration with Japan. See, if you have to return a sample from moon to Earth, I think the requirements are very demanding. It's not just going up there, but it also has to come back, and you need huge amount of fuel. We launched a Chandrayaan-3 with just 4-ton mass, which contained the orbiter, the lander, the rover, everything, with a lot of propellant inside. But if you have to go there and then come back, beating the gravity of moon, reach Earth orbit, then control descent from Earth orbit to back to the land, then requires much more mass, typically almost 10 tons of mass. But if you have to launch 10 ton of mass, we don't have a rocket to launch 10 ton, but we want to still bring the sample back. This is our goal. So we are going to do in a very ingenious way now, using 2 rockets, launch 2 different multiple payloads, and then do orbital docking experiments to make them as single units and go to moon, and come back, again de-dock, de-dock, and then come back to Earth. So this is a technology. I am not going to explain the total part, how technical element of all of that, because we are still currently working on it. And we are very excited to see that a lot of new things are in this mission. It's just not the sample that is going to come up. Even the mission management is going to be very interesting. A lot of new elements comes in. So let me tell you some of the enablers if you have to really bring back a sample from moon. Even if it's simply a piece of rock to bring back, it's not going to be an easy task at all. But this is going to be a precursor for us to send human beings to moon and bring them back safely. But that will be using a much heavier, complex rockets and propulsion system. But even with the available technology, we would like to do this mission in very short time, like 2026. And that's going to be the challenge. And not waiting for developing a new rocket or a new propulsion system. Let me dwell quite a little bit on the Gaganyaan program. Yes, all of you are aware of the Gaganyaan program, possibly through whatever you have read about it. And we are already in the process of developing the crew module, the service module, the new rocket called the human-rated LVM-3, and also the test vehicle, which we have launched recently. The test vehicle has the top portion is identical to what you see in the full vehicle, where we have done a test to demonstrate its abort capability. That means if anything happens to the rocket at any point in time in the flight, we should be able to save the crew. So we do not know when it is going to explode, when it is going to divert from that planned trajectory. And we must detect it much ahead of it and then take a corrective action if possible. If not, we must abort the mission and save the crew. Save the crew means we need to take the crew module at least 1 kilometer to 2 kilometers away from an exploding vehicle in very short time. So for that, we have a new set of rocket motors which are very fast acting. And in case you detect an anomaly, it will separate out from the main rocket, move away at very high speeds, typically at accelerations like 10 times the gravity of Earth. So the astronaut will have to suffer that much of acceleration for a very short time. Possibly they will be able to do that. And then bring back the crew module using parachutes into the sea and collect them from the sea. So this is very crucial for the Gaganyaan program because we cannot afford to have the crew lost at any point in time. Even after they go to orbit also, we must have abort capability. So we will be testing so many such abort situations in the coming days. The series of Gaganyaan program involves building rockets of multiple numbers, but the bigger challenge is in building topic like launch vehicle health management system. It looks like a black box there with a lot of connectors, but the essence of it is a set of computers. It will look at the entire rocket as an object and then analyze the data that is coming from various telemetered parameters, sensors, etc., and make a sense out of the whole thing in a very logical manner to find out that, yes, the rocket is better to be aborted today and crew can go. So one command only will come out of this after analyzing all of this, abort or do not abort. So this package is designed to handle that, and no human being can get involved in this because the things are changing so fast. So a human being cannot decide based looking at the trajectory or looking at the data. None of us can decide that fast. Seconds. Possibly a computer which is configured now, which is a triple modular computer, TMR, and will decide by internal voting system what computer is right, and then make the decision to abort or not to abort. And this is going to be very crucial for this. It can also give wrong signal also, so we will have to protect against wrong decisions as well. Another important area is the astronaut selection and training and human-centered technologies, especially the environmental life support system and all others. And also crew training, the facilities, all of these are being developed currently at ISRO's facilities all across the country. So I mentioned about some of the scientific missions, the rocket development, the Gaganyaan program. So when we mentioned all of this today in the aftermath of the Chandrayaan-3 success, there is a huge demand. What is next for us? What you are going to do in the long term, in next 25 years? A sort of a roadmap we prepared, and I would like to present to you this roadmap. From now to 2047, when we look at the space sector, I mentioned that there are a lot of work I mentioned about the satellites, so much of new technologies. In the application domain, we have to work. But we have to also look at an exploration aspect of it. So we said that we can look at building a space station, we can send human beings to moon, and we can create a moon-based economic activity in space. So for all of that, we need to work out a long-term map on how we can develop the capability over a period of time and ultimately reach a goal of reaching human beings to land on moon, create moon base like many other nations are aspiring to be at extremely lower cost than anybody else could do. So this is a great challenge for us. So how to accomplish is something which I have depicted in a very simple sketch, and I'll explain it a little later in my subsequent slides. First and foremost is to build a Bharatiya Antariksha station. I think all of you know that a space station has a lot of benefits. It's a satellite permanently in orbit. You can go up there, go and work. Your lab equipments will be stationed there. You have a microgravity environment present, which is very conducive for conducting microgravity-based research. And you are going to have a Gaganyaan crew module, which can go up and dock with it, send human beings up there. And the microgravity research capability is actually huge today. If you look at ISS and the number of research activities happening there, hundreds of research activities still being supported by the many nations who are partners in ISS. They are into medical science, material science, biological science domains. In India, there are only small teams working in various institutions, but I don't know in IIT Mumbai this is happening. We will look for possible activities in microgravity research, especially in material science, biological science, medicine, additive manufacturing, etc., etc. So one of the things which I came to know recently, somebody proposed that manufacturing a fiber optic cable in space in microgravity will actually yield a quality of the crystals of the glass will be of so high that your data rate capability through that fiber will be much multifold than that could be realized on Earth. This is one example. A few kilometers wire can be drawn there and used in sensors like the optical gyroscopes, etc. It's really going to be very good. So there are many, many such possibilities. So we would like to look at a space station that is conducive for research and looking at how we can build it over a short period of time. So one of the targets is that to build it, the first part of the space station by 2028 and have the full station built by 2035. So why these two dates are coming is because the rocket capabilities are not existing today. We need to develop newer rocket to carry heavier payloads to build a space station like this. And of course, Gaganyaan program has to mature for human beings to go there and do EVA and other type of activities. Otherwise, a space station of this nature cannot be built by remote means itself. The first step is to have ability to dock and undock and do such operations in remote manner. So we call it a robotic activity in space is essential if you have to build such complex space stations, possibly like the solar panel assemblies or external experiments. So we are getting ready with a satellite called SpadeX, which is 2 small satellites. We will be connected together while it is launched. After it reaches orbit, it will separate out, then move about few kilometers apart and come autonomously to connect each other once again. So this is a space robotic experiment we are going to do with a lot of sensors, which with its robotic arms, artificial intelligence driven location identification, control software, lidars, etc. As you have seen today in the exhibition, you have seen the cars which are obstacle avoidance. Like it is much more complex than that. We need to orient in 3-dimensional space, and especially in space itself to so much accuracy to have this soft latching of the mechanism between these two. And the satellite is, I want to tell you, this is ready now. In our laboratory, these 2 satellites are ready. We are conducting now experiments to do the docking, undocking in the zero gravity environment using a pneumatic bearing system. And it's working very well. And possibly we'll be able to launch by next year middle. We are also looking at how to make a tethered robots that can be deployed from a rocket, which will go up there and do some capture of some objects and bring it back. So this is also almost the prototype is ready. And we are also deploying a multi-arm robot for grabbing and doing repair, etc. So all this put together, we'll have a launch in one of the PSLV upper stages. And I have seen today some of the capability that we have in IIT Mumbai on robotic activity. I suggest some of you should join in this exercise and contribute towards robotic activity building in the future in space sector. We are also working on something called ISRO Servicer mission. This is a satellite which will go up there and do refueling of the satellite, which is almost at the end of its life. But it requires some interfaces to be created for fuel filling, like a car. You have to open the tank and then you have to refill. It's not like that. You have to have a specific type of connectors and interfaces, both electrical and mechanical, to do this. We are also looking at how to attach another unit to a satellite so as to extend its life in case of damaged items are there. So such a fuel depot is under consideration now. We are already configuring such a satellites for future maintenance and repair of already existing satellites. We have to develop a new rocket. I was mentioning everywhere that unless you have a heavy lift rocket, you are not going to do the future missions. So we have named it as NGLV, New Generation Launch Vehicle. Possibly the names may change. But it's going to be based on a locksmith engine. The engine currently is already designed by ISRO. And we are currently in the process of prototyping now. And we have started testing of some of this in smaller levels. And this is a cluster of engines, which is a reusable engine, throttleable engine, which will enable us to have vertical landing of this rocket in the future. The first stage can land. And the entire rocket is based on a single engine concept as done elsewhere, but with different capabilities so that the manufacturing will be easier and modularity exists and cost also can be controlled. So this is another development program. And once you have these rockets, the space station and the Chandrayaan series of work that we are planning to do, we hope that we will be in a position to lead it up to an operationalization of the Bharatiya Antariksha Station by 2035 and landing of the person on the moon by 2040. So even to go to moon, I mentioned about only one experiment called the sample return. That's not enough. We need to have more robotic missions to moon. We must have unmanned missions to have circumnavigation of the moon and come back to Earth and recover back without human beings. And multiple times we have to do this before we actually send a human being to moon. So it's not going to be a very short journey, as I mentioned very quickly in this PowerPoint, but it's going to be a very prolonged, very stage-wise accomplishment program like the Gaganyaan. Then only we'll be in a position to do it in 2040. And don't think that 2040 is so far away. It's so close. It's only a few years away from now. And unless we put that very committed effort on accomplishing it, we may miss it very easily. So there are many technology elements that need to be built to accomplish it. Especially for India, we cannot demand huge money for it also. The whole challenge is in able to accomplish it with frugal engineering and very different approaches that has been done by others. For example, if to send a human beings to space, we need rockets like the Saturn. And impossible to develop a rocket like Saturn today. And we are not going to do it also. So one of the important challenges we are going to face is how to do human spaceflight missions to moon without developing a very powerful rocket. So this is a bigger question that we are going to answer. And the answer to this is that you do multiple missions of the same rocket, build it up the whole unit in space, around Earth orbit, and then go to moon and come back. So this is the type of approach that we are going to follow in the future. And how successful is going to be, only the time will tell, but this is a concept today on which we are going to work. So that the overall mission cost, reusability of the rocket, etc. can be ascertained. Even after moon mission is over, the rocket will be still available for conventional launches, etc. Otherwise, a rocket like a Saturn, if you develop, it can be used only for moon mission, and there will be no utility for it for anything else. And India cannot afford to have such a concept at all. We need to build new launch pads. I think this is again new things, because if you have to take up heavier rocket launches, the current Sriharikota launch station is just not enough. And we are already planning to build this launch station. And I can tell you people that we have already completed the design of this new launch pad, and the whole project is in the process of approval. Of course, I mentioned the journey of rockets development program, and we would like to see a series of rockets being available in India. Today we know PSLV is available, GSLV is going to retire, LVM-3 is going to be upgraded, and new players like the small satellite launch builders like the SSLV, the Skyroot, the Agnikul, all coming up now. So I hope that the smaller markets, smaller satellite launch markets will be served by the private companies, and the medium scale will be served by the PSLV, the heavy lifts and the interplanetary missions will be served by the NGLV. So this is our hope that it's a working together of the private companies and Indian space program together will lead to a very varieties of launch possibilities in India and really become a potential place by which commercial launches can happen in large scale. We are also working on new technologies like electric propulsion. Possibly you are aware of electric propulsion. It's based on inert gas, which is converted to plasma and then going to be used as a thrust developing element. A 300 millinewton type of thrust electric thruster is already developed, and we are going to have a mission called TDS-1, which is a technology development satellite with a communication payload. We are going to launch. The satellite is just under integration now. The electric thrusters and power processing electronics is under testing process. So in another 3-4 months of time, all of them will be delivered, and we will be in a position to launch this satellite full electric propulsion and no chemicals propulsion inside. To take it to the geostationary orbit, it will take almost 6 months to travel from the rocket where it is injected to geo. Though it takes longer time, but it's more energy efficient. It is much more lighter in weight. So we can pack 2 satellites at the same place of chemical propulsion, 1 satellite. So that's the type of efficiency. We are working on green propulsion. Of course, in IIT Mumbai also there was some work done on it. Locksmith engine and also nuclear propulsion in coordination with our atomic energy department. So this is also a new work we have started. And we hope that some space-based nuclear propulsion can be developed for long-term interplanetary work, and they are very keen on them to do this. Bringing down cost of launch is one important agenda for all of us. We said that the SSLV is one step towards bringing down the cost of launch. We were able to build a rocket with a 500 kilogram payload capability at 1/10 the cost of PSLV. And it is not it was using conventional methods of materials, manufacturing approaches, etc. We are able to bring down the cost. But when the next step of bringing down the cost is developing a huge rocket with reusable capability. And another approach is to have winged vehicle which will continuously go up and land. But each one of them have their domain of usage. For example, winged rocket cannot take heavier payloads. The SSLV also cannot take heavier payloads. So heavier payloads will be taken up only by the reusable rocket, but the other rockets will serve at multiple segments. So we have a plan by which the rocket capability, launch capability are distributed over various user segments. So that's very key. And we would have seen this video of the landing of the RLV. I believe that some of you would have watched. If not, go to the ISRO site and look at it. It's an aircraft-like structure landing at very high speeds compared to any other aircraft that is landing. Even fighter aircrafts don't land at these speeds. So we are working on so many different technologies. As I mentioned while in passing, a lot of new technology developments are happening in ISRO in various ways. And we would like to make sure that you become partners in IITs like this has to contribute to this. And through the faculty and other engagement that we have specific time-bound projects to meet them. But then it's very important that we engage in R&D activities as well, whatever is required for ISRO. These are some of the missions that happened recently. This year we had an exciting time and many new missions that we could accomplish. The LVM-3, the OneWeb mission, which was a commercial mission which got us a lot of money using the launches. The Chandrayaan-3 mission, which got us a lot of glory. And the OceanSat mission, which again brought us a lot of valuable data. Of course, the launch of SSLV, GSLV were after failures, and we were able to overcome 3 major failures this year and make it successful. The Chandrayaan-2 failure we could overcome and make Chandrayaan-3. SSLV D1 failure we succeeded in D2, and GSLV launch also we made successful this year. So it has been and also the Gaganyaan program also got a fillip with the type of launch we happened in the TD1. We are also enabling a lot of private companies to come to ISRO and work with us. I think possibly you are aware some of the rockets we launched, sounding rockets was launched, as well as their engines were tested in ISRO facilities recent times. And we are hoping that will take them to make their launch vehicle launch happen soon. The whole purpose of all of this, what we have discussed today, is out of the vision of the government to build a very sustained, long-term space economy around whatever we are doing. We hope that over a few years of time, our contribution to the space economy from India should increase substantially. It's not by building rockets and satellites alone. It is by building applications. I think possibly you are all aware of the application side is something which is still not explored or exploited in the private domain. For example, satellite data is still not being utilized by in a commercial manner largely. It's still resident with the governmental agencies for various activities like the agriculture, natural resource mapping, cartography, survey records, etc., etc. But there is a huge potential for people to make use of the satellite data, make intelligence decisions out of it, and convert it to commercial possibilities in the future. And some of the examples of some of the companies today, you are open to read them, understand them. You will be really wondering how young people are transforming the way in which satellite data is being utilized and commercialized. You can actually bring fusion of the communication, remote sensing, PNT, that is a position, navigation, and timing services into satellite data and service various sectors. It could be many. It left to your imagination. For example, one company recently, I have a demonstration done by them. They simply give agricultural crop yield assessment, which will help us banks to give lending. It is wonderful. You simply select the patch of land where you want. It will give you the type of current crop estimate, the growth rate, the disease, the pesticide, the water stressing, the nutrient stressing. It also gives you the previous data and analyze it to give that future what you should do, how do you rotate the crops. All of this comes in just few minutes of time, type of analytics that they have built into satellite data. So we look at how the overall space economy can be increased by working on applications. That drives the building of new satellites, and that drives the building of new rockets. I think this is a chain of activities that we would like to see to happen, so that our space economy share will grow. And whatever I mentioned are of inspirational nation-building type of missions. For example, strategic missions are very important for the nation. The exploration missions are very important to have our pie in the whole of the affair when the entire world moves towards that. And also to support the scientific and engineering talent in this country to continue work on advanced missions and complex problems of this nature. So together, we should be able to make a very substantial contribution to the space economy from India. So let me conclude my talk and wish you a very happy New Year 2024. And it's open for questions. Maybe Professor will take.
So I don't have to mention that Shri Somnath has covered ISRO's plans, current as well as future, in such detail that many of the questions that I had in mind for asking sir has already been covered. So in the interest of time, I'm just going to pick a couple of quick questions for response from the chairman. One of the interesting questions which has come up is we've launched across the globe hundreds of satellites over the years, and many are in the pipeline. So is there a plan at ISRO as well as globally to address the issue of space debris?
Of course, the space debris is an issue which is being discussed all across many fora. There are United Nations fora, there are other forums like International Agency for Debris Coordination. India is also a partner or participant in such discussions. I know all of you are aware that large number of debris, not only the functional satellites, non-functional parts of the satellite, exploded pieces, and natural debris are all there. And this is going to cause a huge amount of threat. So there are many directions coming. One is, of course, is to have better guidelines to minimize debris. And this is by disposing of all non-functional satellites. So this is one direction. Dispose of the low Earth orbit or even geosatellites at the end of its life should be taken to graveyard orbits or re-entered into Earth so that it doesn't remain there for a long time. Second point is that do not have an explosive element left in the satellite or in the stages of the rocket once its function is over, so it all must be passivated. So this is yet another direction. Third is that you must have a data exchange program between different nations so that you do not collide each other. So its position locations are shared globally and observed globally, and we coordinate this work to do the mathematical modeling and analysis of how they travel around the space and when they are likely to collide. So these type of assessments are important for any corrections or movement to mitigate such threat of collision, so that if you collide, two satellites will become thousands of debris, pieces of debris, which is very dangerous. So these type of things happen. But then there are other movements which is happening, that some companies are coming up with proposal. If there are different satellites, send a small satellite up there, dock with that, and deboost it to the Earth so that big satellites can be removed from, actively removed from debris numbers. But all of this apart, there is a big challenge which is coming up in terms of smaller debris which cannot be even seen, because anything below 10 centimeter cannot be seen by the standard radars. But then there is an effort to build radars of much higher detectability, but still how to collect them, I think nobody knows. Suppose there is a debris of 5 centimeter moving at tremendous velocities like 10 to 20 kilometers per second. I don't think there are any good technologies identified today to even to capture it and bring it back. So people say you take a net and then spread it and collect it. It's all not practical solutions. But then there are some new technologies start to come up to remove it. So only way today is to minimize creation of debris and have some international dialogue on this possibility so that people don't randomly put it, but with a very controlled manner, it is done.
Thank you very much, sir. Another question was about ISRO's plan to have any deep space missions going beyond solar system and let's say like the Voyager or something like that. Is there any plan for that?
No, right now, deep space missions are, for us, even going to Mars is a deep space mission. So we are going to, MOM was launched, so it was a deep space mission, interplanetary space. But deep space mission required much more investment. For example, it requires global tracking. So we need to have ground stations all across the world, multiple places. And after that, we need to have communication, which is a huge infrastructure, not a small one. We have only a 30-meter diameter antenna today to communicate up to Mars. But if it goes beyond that, this will not be usable because in terms of signal strength. So then it also requires physically separated antenna placement. All these are important. Right now, we are not identified as a need to go beyond Mars. Possibly, we may look at it a little later.
Thank you very much. So in the interest of time, I'm willing to open it up for two quick questions if there are any two quick questions from the audience. Can someone pass the mic around? We'll have two questions from the audience. Is there a mic around? Somebody can. There.
Mic, they can speak.
Yeah, please go ahead. One of you can go ahead and.
Yes, please speak. See, the green here refers to is the fuel that won't be causing any pollution. For example, if the combustion products are water, we don't treat it, even carbon dioxide, we treat it as green. Now, the one which we showed was more of hydrogen peroxide-based, catalytic-based decomposition, or converting hydrogen peroxide into a bipropellant combination with other ionic liquids, so that you can actually create a bipropellant type of situation. You mentioned about the cow dung. Actually, the cow dung is not the fuel. I think that you have not read it well. The cow dung is used to create, I believe that the reporting is not very well done. It is a methane. So methane can be produced from any natural sources. You can probe from vegetarian residues or anything else. So if you use cow dung, you can get methane. You can also create methane by natural sources. You can synthesize it and use it as a rocket fuel. So methane is the future fuel. So it is very clear that it is more greener, it is simpler in composition, it can be even synthesized in space because of the carbon dioxide and water can be used to create methane by Sabatier reaction. So it is really the future fuel. And of course, some companies did it with cow dung. Of course, cow dung is also possible. And many other natural sources of methane are there. Yeah.
So one more question, maybe from this side. Please go ahead.
You can come to the question straight. Yeah, that's a fact that you mentioned. I agree with the fact. Okay, I think that suggestion has to be given by you, the students of IIT Mumbai. See, there is nothing wrong in aspiring higher. I don't find it's a wrong thing. But at least some of us, some of you, should try to join ISRO. So that only I can suggest. See, and I don't have all the vacancies reserved for IITians alone. It is through it's a national competitive process that we recruit people. I think all of you are welcome to write. And if you are inspired to come and work in ISRO after that, with the salary of the government, then you are most welcome.
Hello, sir. So on that note, I think I have to wrap up here. Sir has a very tight schedule. We will have to wrap it up here, sir. Thank you so much.
Thank you so much, sir, for such an insightful discussion. So there is one last question from our side, that how can students cultivate and sustain motivation along with enthusiasm for their studies, even in the face of failure or academic setbacks?
I didn't understand the question very well, because while you are a student, you are not going to face any failure. The failures are going to be faced only when you go to your professional tasks. The failure of passing an examination is something which I cannot help you. Because that is a minimal academic requirement. So that, of course, you must go through. But the failures that you are going to face in real life are of a different kind. It's not of the kind that you are going to face in an examination. They are of individuals' ability to reach or not able to reach. But in a collective profession like ours, and if you face a failure, it's a huge issue. So it has multiple levels of elements in this, which includes the decision-making ability, the comprehension ability of the team, the way in which that you handle the whole project and the management aspect of it. Ultimately, we say all failures are management failures, not technology failures. So handling failure and coming out successfully is a big issue. And this shows the ability of an organization. I think we have been trying to work out in space sector to have that resilience to come out of failures. And that will happen only once after your studentship is over, you join an institution, whichever may be the institution or place where you're actually doing it. You will learn there only. I can't explain it in whatever ways you won't follow it.
Thank you so much, sir. So moving ahead, I would like to call the SOF winners on stage for a photograph.
Okay. Then you want to ask question?
Give a huge round of applause, guys. Thank you, sir. We are deeply grateful for your invaluable insights and gracious participation, making this event even more exceptional. Now, I would like to invite Arnav to the stage with our memory booklet, a beautifully crafted compilation of memories capturing the essence of Techfest Iit Bombay. Give a huge round of applause. As a token of our appreciation and as a symbol of the lasting impact your presence has had on this event, I would like to request Pavitra, the overall coordinator, to present the memento to Sir. As we draw attention on the lightning event, it's my privilege to extend heartfelt gratitude on behalf of each of us who graced your presence today. Thank you all for being part of this event. अरे भाई, इस advisor लगाना है? Everybody, please settle down on your seats. इन लोगों को क्या Kindly settle down, guys. There will be 5 minutes till the gate will open.